let's do this problem. Course schedule 2. We are given a total of n number class courses you have to take, labeled from 0 to n minus 1. You also given an array where this array contains 2 entries. The first one, you need to take the second one first if you want to take the first one. For example, here in this pair, you need to take 0, course 0. You need to take one first to take the zeros, and return the order of courses you should take to finish all courses. If there's any valid answer, you can return. If it's impossible to finish all the courses, you need to return an empty array. So this is signature. We are given the total number of courses and the order about each course. Because the ending goal is we try to finish all the courses. We can using the so-called topological sort algorithm to help us. It will breaking down some steps. First, we will build the graph and integrate status. Second, next one is push 0 integrate node into queue. Then we run the BFS record all valid node into a list. Last, check the list length equal to n, which means we can finish all the course. We can return the list. Otherwise, we need the return the empty one, which means there are some isolate or dependency. We cannot finish all the nodes. Okay, let's start to build our map. The map, I usually use like the number of the mark of the course and the following the list of the course we can take after. The degree, it's either we can use the array or we can also use a map. I will stick with the map, but we can use array here because we know beforehand there is a number of these courses. Okay, so now first every entry I will give it a start point. Now we will loop every information from the given array. The previous one is the second one, and the current class is the first one, which means integrate the current one. We need to have some dependency. We need to take the previous one first, so the current one degree will increment. Also, we need to go to our graph to get the current one. Add the no, the previous one, add the current one. Cause, for example, here, we need to take one first. One is the current one. Yes. One is the previous one. The 0 is the current one. So the current. Let me try to clear everything. So this is the previous one, and this is the current one. We need to take the previous one first, then take the current one. So the current one have dependency, depending on the previous one. So the integer of the current one should increment. Otherwise, on the other hand, if we want to build the graph, which is the dependency graph, the previous node, if we want to take the previous class, we need to, oh no, yeah, what's the definition about this graph? Let me reclaim. The graph means the relationship between now I'm taking the class, for example, I'm taking the first class. After I take the first class, I can take the others, for example, the other 3. So this one should be the previous one, and the 1, 2, 3 is the next one I can take. So it's the current one. We can name this guy more clearly to be more clear. It's not current one. Let's rename it to the next one for better understanding. So the next class have dependency from of the previous one. So the next course will have increment the integrate, and the previous class, after I take the previous one, I can take the next one. So we add the next class to the previous ones, the list, like this one example here. Okay, now we push the 0 degree node into our queue. First we have a queue here. Inside is the cross. Iterate order class. If the integrate of this class is 0, which means we have no dependency, we can directly take this class. We will offer this class into our queue, serve as the starting point. Now we will run the BFS here, and we need to have current classes. We already taken class. While the queue is not empty, we continue to get out the queue. This is the current class. So we add to our classes current one. For the next class, we're looking for the graph current one, if any of them, and because we already take the current one, so the next integer will be decreased by 1. If the integer of the next class becomes 0, we offer, which means they have no dependency, we can directly take this class in the next round. We offer this class into our queue to continue to run the BFS for us. Okay, so if we run out of this loop, it should give us the final length of the list. Let's say check if the classes size is equal to all the courses. In that case, we will return an array. First to let's say it's not equal. We will return an empty one. New integers, right? If it's equal the size, so the result integer will like this one, size is this one, and for each course in our classes, we will have this put into our result. Class give the index help us to identify which location we are assign these guys into the final result and return the result. Why is this guy give me an index, the syntax error? Already mentioned missing. What I want to do is return an empty array. So how is the syntax not like this one? Dimension I gave you 0. Let's try it. Okay, it looks like it works. And let me try to submit. Luckily we got accept. Okay, cool. And let's try to analyze the time and the space complexity. For the time, here is on, it's on, it's still on. While looping, every time we just get from the queue, it's constant. And for all the dependency one, it's also constant. So the time complexity will be on. The space complexity will still be on. It's depending on how many nodes we have. So the time and the space will be big O of n, both depending on the input, how many classes we have. Also we have this guy. This means all the edges. Potentially we can have all the nodes connecting together. So the space can be all the edges, and the time will also be the node plus the edges. Let's double check with this editory answer. First approach, DFS. We are looking for the BFS one. Node integrate. I think this is what we are using, the same technology here. And as we can see, the space and time complexity is the vertex plus the edges. Same thing as here, it's the node number as plus the edge numbers. So yeah, that's it for this problem called schedule 2.